Now that we know all the compounds that have been formed, sorry, now that we know all the compounds that have been formed, uh, don't forget our structure. We are following this structure. And what have I so far done? Uh, I have covered synthesis. I have explained how compound B is synthesized and also how compound C is synthesized. That is done. Then what follows? I have previously said this severally that it does see. Let me now proceed to mechanism. And the item always specifies which mechanisms of interest it is interested in. However, it can also be open. Yeah. They can tell you that despite the reaction of this and this, it can specify. However, if it doesn't specify fundamentally, what do I mean? As of now, they are supposed to be two. But if there is any change, don't say that the man said that the information is static. No, this information is dynamic, which is evolving over time. So for now, there are two. If it doesn't specify, if the item doesn't specify, kindly outline two mechanisms for two reactions. That is what I'm meaning. Outline two mechanisms for two reactions if it doesn't specify. If it specifies, then you can outline as many as possible, so long as they are being specified. Hope we are clear on that. Hmm. So, what has the item highlighted in this case? In this case, I think it did not specify why, but besides that, analyze the synthesis of compounds B, analyze the synthesis of compounds B and C. We have done that. We have synthesized them and we have even named them so we know what they are. So analyze the synthesis of compounds B and C and explain the reaction or reactions of compound A. You see? Explain the reactions of compound A, including the mechanisms. If they don't say mechanisms, have it in mind that here we explain the reaction using the mechanism. We explain it using the mechanism. So if you say that it hasn't specified that it wants a mechanism, so I have decided not to apply it, just know that you are in trouble. Yeah, so we explain the reactions using the mechanisms. So particularly if it is not synthesis, yeah, if it is to explain how something reacts with another, we use a mechanism. So explain the reactions of compound A, including mechanisms. Yeah, including mechanisms through which it can be converted into other useful organic compounds. Now, for compound A, what do we know about compound A? Compound A has been explained here clearly that it is hexane. There we are. That is compound A, hexane. Now, this compound, I've said they have not specified that they want the reaction of this compound with the X, Y, and Z. What we know about this compound is that it is an alkane. And I am from emphasizing as far as today or currently, as far as the current trends are concerned, you are supposed to outline two mechanisms for two reactions. Now, if this is an alkane, think about two reactions of it with other substances, and when those reactions have mechanisms. Yeah, because when you don't outline those mechanisms, you are not going to attain some levels of achievement. You are going to miss out on them. Yes. So, what are some of the reactions of alkanes that involve mechanisms? So, previously we have seen halogenation, we have also seen nitration. As simple as that. We have seen halogenation and nitration, isn't it? We have seen that. So, meaning that I must explain using mechanisms how this compound reacts with halogen, particularly chlorine in UV light, and also how it reacts with acid. So we start with that. We start with that. Hope I've interpreted it very well. Yeah. For any inquiries, please ask. Present ask. So now we are on reactions. I have said, uh, I've said, and I have highlighted this very well. Reacts with chlorine. Outline the mechanism for its reaction, and also how it reacts with it. Nitric acid. Yeah. So this is the description we have seen earlier on previously that hexane reacts with the halogens. So it reacts with the. Okay, let me first explain before I demonstrate these wordings. Otherwise, they may confuse you. They may confuse. Mhm. So we must explain how hexane. Where is my hexane? It is here. How this hexane reacts with the chlorine. You can even choose to use bromine, no problem. So note that earlier on we saw that alkanes react with halogens to form. Do you remember? If I've forgotten. For example, if I have, but here I'm not here to recap those things. Yeah, they were explained clearly with plenty of examples. So maybe I take a quick one. If I have methane, this is just an example which I'm going to get rid of. If I have methane reacting with chlorine, so this is a halogen substitution reaction. Why do I call it a halogen substitution reaction? Because chlorine is going to substitute one hydrogen for methane. One chlorine, you see, there are two of them, but one of them is going to remove the hydrogen from methane, so that methane is left with three hydrogens. Then the other chlorine fixes itself there. So one chlorine has removed the hydrogen, so that we have hydrogen chloride. I've said, and I said this previously. If you have an alkane reacting with a halogen, this halogen, one of the halogen atoms, will remove the hydrogen. It will substitute. That is why I'm calling it halogen substitution. The halogen substitutes one hydrogen from methane, so that we have CH3Cl. Then that hydrogen that has been removed and another chlorine combined to form hydrogen. All right. Meaning that if this is my alkane, if this is my alkane, and I am reacting it with chlorine, there is something I explained very well. The concept of primary hydrogens, secondary hydrogens, and tertiary hydrogens. Now look at my compound here. This is my compound. This compound, hope you agree with me. If you don't agree with me, please ask. This compound is constituted by primary hydrogens and secondary hydrogens. A primary hydrogen is a hydrogen that is situated in this form. If I have something of this form, these hydrogens bonded to that carbon, they are primary. They are primary. And if I have a carbon which carries two hydrogens, those are secondary hydrogens. Now, if I have a carbon with one hydrogen, we call that tertiary. Colleagues, I say within this alkane hexane, we have secondary and primary. No, we have secondary and primary hydrogens. Okay, why am I bringing these things of secondary and tertiary, blah, blah, blah? Why am I introducing them in? This is not unlike methane, which only has one carbon atom. Hexane has a lot of carbon atoms. So you need to know which hydrogens are going to be substituted in a particular so that we form the major product. You need to know that. Otherwise, if you just outline the mechanism and obtain a product, that product which you have obtained can be minor. It can be minor. That's why it is important to study this compound very well. So hexane in this case has primary hydrogens and secondary hydrogens. And I have said, I explained this also previously. If you have a carbon with three hydrogens, those hydrogens of it are primary. A carbon with two hydrogens, those are hydrogens of it is secondary. A carbon with one hydrogen, that hydrogen of it is tertiary. On top of that, I explained that tertiary hydrogens are most reactive, followed by secondary and primary are least reactive. So you see, in this case, we have primary hydrogen, primary hydrogens, and these ones in the middle are secondary. These ones in the middle are more reactive than the ones at the extreme end. Meaning that if you want to substitute a hydrogen, substitute these hydrogens of carbons which are within. You can substitute hydrogen of this, you can substitute hydrogen of that, hydrogen of that, hydrogen of that. Hope I'm clear on that. If you outline a mechanism where you are substituting hydrogen of these primary, that will be formation of a minor product. Do you know the major product? Therefore, for that case, this is what we have. This is what we have. So this is the description, and the description may not be so much important. What is important? The reaction and correct reaction mechanism. So here, this is my Excel. This is my Excel. There, that is my Excel. Reacting with chlorine, you have to describe the conditions. Excel reacts with chlorine. It reacts with chlorine in presence of ultraviolet light rays. Reacts with chlorine in presence of ultraviolet light, UV light, presence of UV light in a halogen substitution reaction, which I've explained very well, to form. Now you may not, in halogen substitution reaction to form, you may not know this at the start here. This is something which you can, the name which you can easily see here after finding the mechanism for the reaction. Without the mechanism, you cannot tell. So for me, my choice was this. I decided to go with this carbon there, particularly this carbon. I decided to go with that carbon. So I substituted its hydrogens. It is secondary. Yeah, you can even decide to use this. Yeah. Then you outline the mechanism for the reaction. The mechanism, how it is outlined, that was information explained. First of all, we start with chain initiation. Chain initiation, and it is here. Chlorine undergoes homolytic cleavage, where each of the atoms of chlorine takes the electron it contributed. So you write your chlorine. Remember, chlorine is diatomic. So you write it in this form, like that. So each takes the electron it contributed, that takes the electron it contributed, that does the same, so long as we form, so that we form two radicals of chlorine. Now, what is important to note here is that these are half arrows. Colleagues, these are half arrows. Hope you can see. They are half arrows. Why are they half? I am demonstrating movement of one electron. That is why it is half. That is half. If it is a full, then you are demonstrating movement of two electrons like that. This is full. So that in this case is not valid because we are demonstrating movement of one electron. So after forming these radicals, that is chain initiation, we go to chain termination. One radical of chlorine attacks the alkane. One of these radicals that have been formed attacks the alkane, but it should attack the alkane at the site that will result in formation of a media product. You see, I said that for me, I decided to go with this, meaning that I must expose the hydrogen on that site so that chlorine attacks it very well. So I'll have, this is what I'll have. I'll have CH3, I'll have CH3 followed by CH2, followed by CH and H. So I expose the hydrogen at that carbon. Then CH2